So I'm going to talk about materials, and so at the end of this, what I would like all of you to take away, materials innovation is going to engineer everything that we see going forward, right? And I'll have some examples going here. So one thing I wanted to follow up on what Rajneesh said, right? Over the past couple of decades, we've lost a lot of people who should have been doing core engineering. So I was recently at my alma mater, IIT Madras. I did an audit of the metallurgy department, which I was part of. And 70% of the people who joined within the first year started looking at other things to do, right? Very few people want to continue down core engineering, right? How do we change that? Without that, a lot of what this conference is saying, engineering the future and all, cannot happen, right? You still need core engineering, you need mechanical, electrical engineers who build stuff, right? That's the way things are going to happen. Okay, with that out of the way, my only company slide, which is don't believe everything I say. So this is, so as soon as I got this note that they wanted me to talk about materials and future, so I went and looked at this. This is the World Economic Forum. They put out a report every year. This is the 2025 edition. This came out in June. They talk about emerging technologies, right? So what they do, they ask people to send in their things of what is going the next 10, 15, 20 years. And they got 250 entries. Out of that, then they shortlisted based on novelty, based on impact, based on depth. Look at all of those, right? Everything is materials. Biomaterials, structural materials, nuclear. I thought all the people doing nuclear had died. Nuclear is now hot. So lot of what you are going to see in the next couple of decades is going to be built on materials, which is one of the other reasons we need people to study core subjects, right? Without this, a lot of this won't happen. This is what is going to build the future. I would, among here, academics, people who can influence academia, let's make sure that core subjects are cool again. So the other thing, material innovation, this is a play of words, right? Material innovation is material. It is important. Earlier, we used to think of material as aluminum, cement, steel, iron, right? And even in the old days, Iron Age, Bronze Age. But right now, materials are critical. Even in today's environment, the impact of rare earth materials in terms of what we are doing, all of you know, it is that important. It decides how countries shape their policy and stuff like that, right? Again, so from commodity to capability, adaptability, and strategic, right? So we need to think of materials differently. So from an industry perspective, right? Where do materials create impact? So we just picked a few. Semiconductor, all of us know, and I will talk a little bit more about that. Solar has already happened. In fact, the change in solar has been even more dramatic than in semiconductor, and a lot of us can see it. I hope all of you guys have solar panels in your house. Try to be green. Healthcare, that is one area where materials is coming, and you will see that. I think in the next decade, even your interaction of how you go to the hospital, how you get treated, how you get results back, everything will change. Energy storage, how many of you have EVs? Hope to see a few more. So that will also change the number of, and I will talk a little bit more about that. 3D printing came, went, came again, And I think it's looking for its time in the sun, right? The technology is there, how to make that happen. Um, so, okay, the first thing, semiconductor. It is in the news a lot, and for this reason, so you can see over the past maybe 50 years, the industry came to a certain point. We are now at close to about 500 billion in terms of revenue. In the next 5 to 6 years, it's going to double. Very, very, very few industries have done this, right? And it's going to disrupt everything, right? How can an industry of $500 billion double in the next 5 years, and based on AI, right? Even you read the news every day and the kind of numbers that they're talking about, mind-boggling, right? And India is a very, very good place to do all this. I was at the Semicon in Delhi last week. Lot of energy, 1,000 different booths, exhibits. There were CEOs from different companies over here looking at how India can be the place to do some of this semiconductor related innovation. All this is built on materials. So if you look at the the wafer is basically like a large pizza, right? In that large pizza, you're looking at a 1 centimeter by 1 centimeter chip. In that 1 centimeter by 1 centimeter chip, that's how it's like a multi-storied building. So all that is copper material. And right at the bottom is a transistor. And this has about 60 miles of wiring. It has billions of transistors, and the last line over there, it has 25 different materials in different combinations. So the power of materials engineering. So every time you carry something in your hand, all this goes to make that happen. So if we didn't have this, this is what you would have instead. You would have a 14-meter tall computer to do the same thing that you're doing with what you have in your pocket. Again, the power of materials here, you see for all the material scientists over here, you see all the different kinds of materials that went in. So one thing, I have to mention Moore's law for anybody here who's involved in semiconductor material science. So they keep saying that Moore's law has died and all that. So this gives a sense of what happened, right? Every 2-3 years, things used to change. It is taking longer to change, and that's what the impact is. And why does this matter, right? So if all of us talked about AI, even in the previous session, there was a lot of talk about AI. One thing that will stop AI is energy. If we continue building AI data centers the way we do not have enough energy in the world. Even today, AI data centers are taking as much energy as some countries, Norway, and the amount of energy that AI data centers take is the same as some countries. If we continue, it will 2035, you won't have enough energy left, right? So that's one big reason why we need to do something about it. And materials is what will do that. So in the past, whenever we've had power kind of requirements, materials have been what have brought down the energy. So we had polysilicon, we had high K metal gate, and we had different interface engineering, and this is what is going to bring the energy down. We call that energy efficient compute. So the energy that is required to change one bit. It's a switch, transistor is a switch. How much energy does it take from thermodynamics to turn that switch? Can you bring that down? And that will happen because of materials. So periodic table. This is when I joined the industry, 1980s. There were probably 6 or 7 materials that were there. We added a few more, and today almost every element in the periodic table is used to make anything that you have in your hand. Any semiconductor item uses every item in the periodic table. So we talked about this in the previous panel also from an application perspective, right? How can AI be deployed? A lot of this was earlier random, then a little bit of data science and all that. Now, can we get to the right end of this? Can you use Gen AI to engineer materials, right? That will be a good application use case, which means you can get it done faster. So the way that last column happens, you basically use Gen AI, look at all publications related to materials over the last 100 years, look at what is stable, what combinations work, and then from that you derive, right, what are potential combinations possible. So this, from 100,000, it'll bring your set of things which you do need to do experiments maybe down to 50, right? That accelerates progress. So one way where AI and data can reduce the cycle of engineering. We'll switch to one more area where materials play a big part, which is display, right? So some old people here know CRTs. Used to be occupy a whole table, LCDs, mobile, OLED, and 3D. I think there was 3D came and went. The first 3D came, you had to wear glasses. 10 minutes later, you throw the glass. 1 month later, you throw out the TV. But there is a way that you can come with the new AR, VR ways of looking at optics and all that. All this is driven by materials. So from a, when will we see this, right? OLED is happening today. So I think most people have OLED, either in your phone or in your TV. Somewhere you have OLED. The next set of innovations are mini LED, micro LED. They are coming right now. Cost is high, applications are limited, but as you start, once you start wearing those VR glasses and all that, which are close to your range of vision, you will start seeing these different materials come into play. So from an engineering perspective, there is just that one headset there has lots of applications, from different kinds of electronics, displays, battery, optics. Battery is one of the biggest problems with that, right? The first generation one didn't work because after 15 minutes, your glass ran out of battery. So if you can, even my watch, I need to charge it every night. If you can make it once a week, I'll wear it to bed, right? So lots of areas where materials innovation can make things more usable. And I think that was one of the things I took away from the earlier conversation, was the technology push versus demand, right? Just because it's there it doesn't need to be something that will be adopted. Finally, there will be a use case, there is a sustainability aspect in terms of is it viable and all that. Then the car example, right? So there are three ways where materials impact from an automotive perspective. The first column is shared economy, which is Uber, right? The second, autonomy, which is driverless. And the third is electrification, which is EV. So sort of the holy grail would be a driverless EV Uber, right? So that you have trifecta of all this. And this, a lot of it is where technology is headed. In some cases now, Waymo and Tesla and others are driving towards this in different markets in the US. The middle column, I don't think will ever come in India. So what all from a different technology perspectives will make this happen? One more click. Yeah. Semiconductors for sure. Display, optics, compound semiconductor. I think that's one area where from an India perspective, there is a lot of need. How can, as EVs increase their penetration in India? How can we build charging stations? How can we sustain this? For solar to also proliferate from a energy delivery perspective, you need those converters and all that, which will require a lot of compound semiconductors, and of course storage. So lot of opportunities here for materials innovation to make this happen. And then the last topic in this is just on the battery itself, lithium. Lithium is one of the critical elements that is required to make the battery. Unfortunately, available in very few places. India, there is very, very few places where you get a lot of these. The problem with a lot of this is imported, geographically constrained, and I'll talk a little bit more about that, and how do we look at that, and how do you do some sort of materials independence for this? So that's something to look at. So all of you have heard and read about rare earth materials and where there is an issue. I think there was a very nice podcast. I think New York Times had for an hour on just on rare earth materials and why it's an issue. So the top right column of all the reds is a big, big, big problem. Without that, you cannot have a motor. Without that, you cannot have a lot of semiconductors. Without that, you cannot have aircraft. Without that, you cannot have radars. Without that, you cannot have many of the things that are strategic. Countries depend on all of that. And geographically constrained. So again, that podcast had a very interesting way of looking at how different countries adopted with this. How do you get the materials independence, right? If we go down the path on making a lot of the engineering in new areas which are dependent on these materials, how do we do that? So there are few more topics that I had. I didn't want to go deeper into that. There is a healthcare aspect of materials which we can talk about, but let me spend time in the three key takeaways of what I look at from a materials perspective, right? The first thing is materials requires R&D. In India, that has been short. How do we get more R&D invested in areas around this, right? We do a lot of R&D, and a lot of it is dependent on materials that is imported. The material that is available here is not at the quality that we want. It's not at the consistency that we want. How do we address that, and how do we do it collaboratively, right? So industry to industry, industry to academia, how do we build centers and how do we address that? So I think the government has, from a rare earth perspective, they are going to invest a lot of money. Right now there is a Institute of Materials where they are going to put in about 1,500 crores looking at rare earth materials, and also making some of these materials available at the grade that we need. Supply chain. I spoke a lot about how we can secure these supply chains. Copper today is a big issue. I think copper price went up 100% or something in the last month, right? Without copper, there is nothing you can do. Any electronics, electrical system requires copper, right? Your prices are going to go up. How do you secure materials and which are integral to your engineering and infrastructure? And the third one, talent. And that's something I am really, really, really passionate about. How do we get more people to look at core subjects and something that as being cool and desirable to do, right? So without that, it's very, very, very difficult to think of engineering the future if you don't have talent that can design and that has hands-on experience on systems, materials. So that's something that I definitely want to look at. I wanted to leave some time for questions, so We have 2 or 3 minutes, so we can take 1 or 2 questions.
Thank you very much for the presentation. And was curious, when you were mentioning supply chain and security, how big a role do you see reclamation and recycling in terms of what's already out there? And given the current restrictions on new supplies?
Yeah, I think from an India perspective, I think that's very, very important. In India, we do not throw out anything. And there are companies which are now looking at that. Maybe not only the stuff that we don't throw, we import waste from other countries and try to recycle here and get things out, right? Gold, silver, copper, palladium, platinum. From your I have about 4 or 5 cell phones that I don't use anymore. If you can crush that, I'm sure we'll get it cheaper than opening a new mine. So I think that's a great, great, great thing that we should do. How can we use waste material to get some of these materials? Yes.
Okay. Yeah. Hi. Very nice presentation. I think kind of opening to, traditionally boring, but now more exciting field, right? My question is, largely those 5, 6 countries dominate the world production, right? And they also then flex the muscles from geopolitical standpoint. My question is, as per you being an expert, what do you see the future for India with respect to core materials discovery, excavation, and the whole process of bringing to a point where it can take it to R&D labs? So capacity building and then offshooting that into R&D driven vertical innovation. So where are we today and what is the landscape you see in next 2 decades?
Okay, so I am clearly not the expert on any of that. I'll just give you an opinion. India is material rich.